Welcome to another episode of Salt Air. My name is Tom Hatch and I am the creator of Salt and the CTO of SaltStack. Today we're going to be talking about Salt architecture, but also we're going to be talking about what Salt fundamentally is. The fundamental construct of Salt is something that a lot of people have a hard time understanding. Salt itself is a very large distributed management platform. And so let me talk a little bit about the core concepts behind Salt and how those are built out inside of the system. Now, Salt is made to manage a system. Now, whether or not this system is a full-blown operating system, or whether or not this system is a sensor, a camera, or a container, we don't really care. All we care about is making sure that we can manage disparate systems. So to manage these systems, we first build an abstraction on top of them. We have a remote execution system, and the remote execution system allows us to manage large numbers of systems in parallel, allows us to do complex orchestration tasks. The next thing that we have is what we call the state system. The state system allows us to configure systems and enforce the state in which they are running, so that those systems that we're working with can be exactly what we need them to be. And we can say, yep, this system is configured to be, say, a web server, or a database, or a TV in a cruise ship, or a slot machine. Now, finally, we have an event-driven system. The event-driven system is kind of the antithesis of the remote execution system. The remote execution system allows us to push commands down, but the event system allows us to bring events back up so that we can see what's happening on the device. The life cycle of any device, system, or server, of course, is not a completely static thing. And so we want to be able to see what's happening on these systems. Now, with that core premise in mind, let me talk a little bit about how we organize the actual software to express this system. Now, when we talk about the management of a specific device, that device in Salt vernacular is always referred to as a minion. And so we can have many minions that are under management, and those minions connect up to a master. Now, since this is more conceptual, I'm not going to talk about how we do high availability with a master or a lot of the nuts and bolts, but focus on those three core concepts. The remote execution system comes from the Salt master, and we can send those commands down at breakneck speed. So those commands can be propagated out to tens of and sometimes hundreds of thousands of systems in mere seconds. And once those commands get propagated out to these minions, the minions themselves ship with what we call execution modules. These execution modules provide a library of different routines that are available to abstract or manage those specific systems. One of the great things about these execution modules is that the abstraction of this library is done in such a way that if I've got multiple machines, say a Windows machine and a Red Hat Linux machine and a Debian Linux machine, I'm able to do something like call network.interfaces, and it's going to normalize all the commands and all of the return information from querying those network interfaces back up through the system. That normalization is an incredibly critical component. The next system that I want to talk about briefly is states. The state system inside of Salt exposes a classical configuration management interface. It allows us to write what we call Salt formulas, and those Salt formulas can be used to, in an idempotent and easy to replicate way, enforce what the state of that system looks like. And so since we're able to do this, it's easy to define that I want a system of type X to look a certain way, and then enforce that across a wide range of systems. Again, whether those are web servers running a web application, or if they're network devices, or a storage system or a database, or a random IoT device. Finally, we've got the concept of beacons and reactors. So, the beacons are what's listening for events on the minion. Now, Salt itself, of course, can create its own events, but the beacon allows us to tie into other systems that are on the operating system, other components, so that we can have independent events firing up. And so whatever those events may be that we happen to be listening to can then propagate up through the master to the reactor system. The reactor system allows us to listen to either a single specific event, or it allows us to listen to collections of events, groups of events, or in some cases, even the absence of events. And so the end result becomes that the reactor is tied into the remote execution system, and the remote execution system is tied into the configuration management or the stage system. And so what we can do now is react to those events, run remote execution routines, manage systems in an idempotent way, and we get a complete abstracted cycle dealing with all of the types of routines that we might need to be able to deal with when it comes to managing these individual systems. Now, thanks for watching this episode of Salt Air. We're going to have more talks about some of the more granular components of Salt's internal systems in weeks to come. Thanks.